Okay, and the last page of your notes today is going to be talking about triangle similarity postulates and theorems. And so these are going to look very similar to what we did with our triangle congruency postulates and theorems, but now we're not talking about congruency, we're talking about similarity. And so obviously, if you look at what we did on the last page, when we did the examples with similarity ratio, one of the things that we looked at is that we could look at whether the sides are proportional. Now, on these particular triangles, corresponding angles are congruent, even though we don't have these written in or these written in. Because of the other two being there, we know the third must be, okay? And that's actually the first similarity theorem that you would have. It's called the angle-angle similarity theorem. So you only have to know, on the angle-angle theorem, you only have to know that there are two angles that are congruent, and you automatically know that those two triangles are similar. And that's the only reason for that is because we already know that on a triangle, the angles add up to 180. That's the triangle angle sum theorem. So if the triangles angles add up to 180 and we know two of them are congruent, then we know these third ones have to be congruent because that would add up to 180, and so would this. So that's why you don't have to know much more than that if we're dealing with triangle similarity. Now, if we're still dealing with quadrilaterals, you're going to have to know at least three of them, right? This only works when we're dealing with triangles because triangles, all three add to 180, okay? So let's go ahead and see what corresponds. This is a 72-degree angle. That's angle A. The 72-degree angle over here that corresponds is angle R. So I'm just going to write angle A is congruent to angle R. And then obviously angle C is a 35-degree angle, and you can see that that is equal to angle S, which is also a 35-degree angle. So if these two things are already given, then you have enough information to prove that these two triangles are similar. So then I'm just going to give the similarity statement. Triangle ABC is similar to triangle. You got to be able to label it correctly. If I did A first, that means R is going to be first over here. So ABC would be RQS. And this would be similar by the angle-angle similarity theorem. So on homework 8.3, you're going to be asked to look at the two shapes, see what information is given, and tell which postulate or theorem that we're looking at are the ones that give you the proof that they are similar, okay? So if you're given two triangles and you're given that two angles are congruent, or if you can assume that two. So for example, let's say I have something like this. Hang on, let me draw one smaller. And you're given this. Okay, wait, hold on, sorry. You're given only this. Then you're able to assume that since these are marked as isosceles triangles, those would also be congruent, and that would be angle-angle similarity theorem. You can also use the concept of vertical angles too. So if you have vertical angles and you can make that assumption, then you're good to go. Okay, so you might have something like this. And that might be all you're given. Well, you're aware of the fact that these are vertical angles right here. So if you're able to assume that those are congruent, then you know at this point that you are dealing with two triangles that are similar. Okay, so just be aware of what you're given. You're still allowed to use everything else we've been told. All right, so let's talk about the side angle side similarity theorem. So the side angle side similarity theorem says if an angle of one triangle is congruent to an angle of a second triangle, and the sides including the two angles are proportional, then the two triangles are similar. All right, so this is an example with two right triangles. This could work even if they were obtuse, but I want to make sure that you're fully aware of what I mean when I'm talking about the sides that include it. This cannot be similar triangles if they do this and this, and then they give you a measurement here and here and here and here. Those do not include the angle. It has to be this side and this side. So be very aware of what it means, what it means when we're dealing with corresponding sides, okay? Side angle side has to include the angle, okay? So if you look here at these two triangles, angle B and angle Z are dealing with right angles. And then you can see that the sides that are beside that angle, okay, here and here, here and here, I'm not marking them, I'm just showing you where they are, they do include those angles, okay? Now, this one's a little tricky because they didn't give you the similarity statement, so you got to pay really close attention to how these relate, okay? So if you look really carefully, you can tell that angle Z and angle B are related. You can see that angle C is way out here. What's way out on this one is Y, so C and Y relate, and that means that X and A relate, okay? And then obviously B and Z are the same angle, so they're both 90 degrees. So I'm going to write the similarity ratio of these. So I'm going to go ahead and do large to small this time. It doesn't matter. 15 is what this side is, okay? And so I'm going to relate that to this side and see if those give me the same similarity ratio. Well, if I divide both of those by 5, I get 3/2. And then if I do the same thing over here with this 36 and 24, I should get the same thing. And if I reduce both of those by 12, I do get 3/2. So those two sides are proportional. So let's go ahead and write out all the things that are true to make this side angle side similarity. So I'm going to do side AB corresponds to side XZ, and that is equal to the other two sides. The similarity ratio would be equal to the other sides, BC and ZY. And I'm given that angle B is a right angle and angle Z is a right angle, so those are congruent to each other. Therefore, I am able to make the assumption that triangle ABC is similar to triangle, remember I'm doing ABC, that's going to be equal to XZY. Got to look really carefully. Sometimes they're not going to give you that similarity statement. And those are congruent by the side angle side similarity. Okay, and then one more. And this one is called the side, side, side. So let's say we're not given any angles, but we're given all the lengths of the sides. Well, if you're able to prove that all the lengths of the corresponding sides have the same similarity ratio, then that also is enough to prove that they are similar. So all you need for this one is that the corresponding sides of two triangles are proportional. We mean all the sides. And that is enough to prove that they are similar, even if we don't have any angle measurements. Okay? So these are not twisted or anything, so they're kind of able to see. So this is 2, and this one is 4. You could probably tell that that's 1/2. And then this one's 3 and 6. You can probably see that that one is 1/2. And then 4 and 8. That's also 1/2. So you can see they're all proportional, so let's write them out. AB is corresponding to DE. And BC corresponds to EF. And CA corresponds to FD. And since all of those do have an equal similarity ratio, then that is all we need now, and we can prove that triangle ABC is similar to triangle DEF by the side-side-side similarity postulate or theorem. Okay? Now, I am going to upload to ThinkWave an extra worksheet that is useful for these problems, being able to look at what's given and determine which one of these theorems is the one that proves that they are similar triangles. So you'll have that as an extra practice for the week as well.